All right, welcome to your first blended cat video. Today we're going to take notes on section 1.2. Our learning targets are I can determine if a relation is a function using the vertical line test, and I can identify the domain and range of a function from a graph or an equation. So that means our two essential questions are going to match up with our learning targets. So at the end of this lesson, you should be able to determine if a relation is a function, and you should also know how to identify domain and range. Your vocabulary is coming right off of those slides that you'll find on the haiku page. So you should know what a relation, function, and what the vertical line tests are at this point, at least the definition of them. So these first three examples here, I'm going to use the vertical line test, which means that we're just going to draw a vertical line on this graph. We're going to draw it anywhere, so I'm going to just pick right here, and I've drawn that vertical line and it hits the graph only in one place. So using that definition of the vertical line test, since we only hit the graph in one place, then it is a function. Now moving on to the second graph, if we draw a vertical line anywhere on this graph, I'm just going to pick right here, we see that the vertical line that we drew hit the graph in two places. So this time, using that definition of the vertical line test, this is not a function, it's just a relation. And the last one. Now, that part of the definition of the vertical line test that says that if you can draw a vertical line anywhere on the graph, so it hits more than one spot, it's not a function. So if I picked right here, it only hits one spot. And that makes you think that maybe this is a function. But, I'm going to erase that line. If I decide to draw a line through the graph over here, I see that that vertical line hits the graph in two spots, meaning that this graph is not a function. So if it fails the vertical line test, can't spell and write at the same time. So if it fails the vertical line test anywhere on the function, even though it passed over here and it failed here, then it does not pass the vertical line test, so that's not a function. All right, so moving on to domain and range. Domain is the set of all possible inputs of a function. That's why I use the terms input and output in those definitions of relation and function. And range is outputs, all possible outputs of a function. So domain is all the x's, and range is all the y's. You can also, I like to remember this as domain and range. I always remember it in that order. Alphabetically, D comes before R and X comes before Y. I don't know if that's going to help you, but that's how I remember it, so I know what order they're in. So we're going to take a look at each of these graphs. These are just some line segments right now, and we're going to take a look at the domain and range. Now, before we get into those, we do notice that this first graph here has an open circle, and the second one dot here is a closed circle. So we're just going to quickly review what that means. If we see an open circle, that means that that is not included in our domain or range. Not included. Again, if I could spell, that'd be awesome. But I am a math teacher after all. Not included, which means we're going to use parentheses when we write that out. And for our closed circles, that is an included value. So we're going to use brackets for those ones. So for this first domain here, now domain, remember, is from left to right, and range is going to be bottom to top, or smallest to biggest, however you want to remember that. So domain, if we look left to right, our first value here is at -4 on the x-axis. So we're going to go -4, and our last x value here is +4. So this is an open circle, so that means our left side is a parenthesis, and this is a closed circle, so this is a bracket. Now when we're looking for range, we're looking bottom to top. Lowest value here is going to be at 1, and our highest value is at 5. Again, this is open, so we have a parenthesis. This is closed, so we have a bracket. The next one, we have a domain from left to right here, our furthest left value here is at -5, and our furthest to the right is at +2. We've got a bracket because this is closed, and an open circle means this will be a parenthesis. And our range, we're looking at that lowest value. Don't let this trick you. Even though we're used to reading left to right, our range is bottom to top. So the lowest value, even though it's way over here on the right, is over here at -2. And our highest value is at +3. So now when you're checking your points here, our lowest value is an open circle, so that's a parenthesis, and we end with a bracket because that closed circle. All right, the last one here on the front of my note sheet, on the left, we're starting at -3, and to the right, we're going to +5. Both of those points are closed, so both have brackets. And the range, our lowest value is -3, and highest is -1. And we've got brackets on both of those as well, because those are still closed. Okay, now on the back of my sheet, for you guys taking notes separately, we've got a square here. Our domain, again, is left to right, in case you need it, left to right. So our furthest left value here is at -4, and the furthest point we have to the right is a 6. Now, this is a closed shape. There's no open circles anywhere on it, so we've got brackets around the whole thing. Our lowest value on this rectangle here is at -4, and our highest up here is at 5. So again, we have brackets. That's bottom to top, smallest to biggest. Now, we've got this diagonal line for number 8 here. Diagonal line, now if we look left to right, we see that this is going to continue forever in the negative direction to the left and continue forever in the positive direction to the right. So that means that we're going to start at -infinity and end at +infinity. Same thing is true for the range. This is going to continue all the way down to the negative values and the positive values. So our range is -infinity to infinity as well. And this last one, number 9, we've got a horizontal line segment. It's starting at 3, +3. Oh, I'm sorry, that's -3. Starting at -3 and ending at +6. We have a closed circle here, so that is going to be a bracket, open circle down here, parenthesis. Now you'll notice that our range here, there is only one value, nothing higher or lower than 1. And we are going to have brackets on both sides of this. Now I know that may be misleading because of the open circle that you see on the right. But if we have that included anywhere, then it doesn't matter that this is open. It's going to include that point in the range because it's included somewhere. At this point, in order to move on to our next few examples, you are going to need your graphing calculator. So hopefully you have that handy. All right, so take out your graphing calculator, and you're going to use that for this first one here. I've got x squared plus 5. So I'm going to just type that into my graphing calculator. So I have x squared plus 5. Type it in, and I'm going to go ahead and graph that. And my graph is a little thrown off here. If your graph is the same as mine, you want to center it. Hit zoom 6. That's going to be the standard 10 on every side. And you'll see that you have this little U shape here. So we're going to look at this picture to help us find the domain and range. So if I look at this picture, now this is going to continue going up in both directions. So my domain is actually going to be -infinity to +infinity because we're including all x values. We can think of this U shape as going forever and ever in both directions, to the left and right. But the range, you'll see that we do have nothing lower than this point here, and our equation will tell us what that number is. So in this case, that number is 5. So our lowest value on our range is 5, and that graph continues to open up and head towards infinity. So we have a bracket at 5 because that's the lowest value, and a parentheses on infinity. I didn't mention this earlier, but the reason that we use parentheses for infinity is because we're approaching that value. The same thing when we have an open circle, we're getting really, really close to that value, just like in number 9 here. We're getting really, really close to the value of +6 on the domain, but we're not actually going to include 6. We might be at 5.9999999999999, but not 6. So we are approaching it, but not including it. That's why we use that parenthesis. So same thing here. When we have negative infinity to infinity, we know that we're gonna go with forever and ever towards the biggest number and the smallest number ever, but we don't know what that number is, so we can't include it because the biggest number you can think of, you could always add 1 to. So we're gonna be approaching that biggest number ever, so approaching infinity. Now this next one is a little tricky to type into your calculator, so I wanna make sure that you're doing this with me when you try to type it in. So, you can see this. So we have a numerator and a denominator, and you'll also notice that we have a denominator that is made up of 2 different binomials. So I'm going to use parentheses when I type in that numerator, 9x minus 2. Then the division bar, that's going to separate that denominator. Now I'm going to hit a parenthesis, I'm going to hit a second parenthesis, because I'm going to include the whole denominator in that first parenthesis, and now I'm going to start typing x plus 5 in that second one. So x plus 5, close that parenthesis. Let's put that so you can see it there. And then x minus 7 is my second set of parentheses. So x minus 7. And then closing the denominator as well. And now I'm going to hit graph. And so I see this goofy kind of looking graph. This is a rational function. Those fraction type functions that you see right here is a rational function. And we have this interesting shape. So if we're looking at our domain here, we see that as we're moving from the left to the right, there seems to be an asymptote that this graph is skipping. So we're including negative infinity until we get to some sort of value here, picking up on the other side of that number, continuing towards a different asymptote, and then picking up on the other side as well. So we're going to start off our domain. This is going to be a big domain, so you're actually going to write it over this. So we've got negative infinity. Now we're approaching a value. We don't know what that value is, but our denominator is actually going to help us out. So our denominator here, if we were to solve this, x plus 5, that would tell us that x is equal to negative 5. So this value here, we're going to actually hit trace, and I can show you that. That we're approaching. If you look at my x values, you'll see that I'm approaching negative 5, and then when I jump, it never actually hits negative 5, and I jump to the other part of the graph. See that it's going to jump from here to here when I get close to negative 5. And then it jumps over here. So we don't actually include negative 5, so that's something we're going to skip. So we've got negative 5, and then we're going to pick up on the other side of it, and that middle piece of our function here, so negative 5, all the way till we get over here. So if I still have the trace key on, I'm going to arrow over to the right, watch the little spidery guy. You'll see that my x values over here are continuing to increase because I'm going to the right, and I'm getting really close to the number 7. And once I hit 7, I've jumped to the third graph here. So that 7, our denominator tells us that the asymptote's at 7, and so we're approaching 7, and then we're going to include our last piece there that's going to go from the asymptote of 7 towards infinity, and this will just continue forever. Our range here, since our middle piece of this graph actually looks like a cubic, we are including all of the numbers from top to bottom or bottom to top. Our range is going to be negative infinity to infinity. The domain, and we're done with that one. So now we're going to clear out our calculator again, type in our third graph that we need to type, second square root of x minus 3, and graph that. And we see a square root function. Now you'll notice that that only starts at positive 3, because that is telling us that we're going to start at positive 3. So our domain here is going to be 3, and that graph continues on to the right forever, so that's into infinity. And our range here, if we see that we start at 0, and this is going to, it's growing really slow, but it's continue growing, this is going to be from 0 to infinity. This next one here, we are going to type in as x cubed. So x cubed, we type in x, and then hit math. You can see the cubed is the third one down. and that is minus 2.